Hi fellas, this is Chemaddicts again to the solution. Welcome back to another video tutorial. Well fellas, it's been a long time. It's been a long time without you fellas. I know fellas that I have disappeared for a long time. We haven't meet for a long time, and it's a history. I know. So I'm back fellas. Sorry for that fellas. Sorry for not making video tutorial for a long time. So I'm back. Okay, so fellas, today we're gonna study the question paper of Pearson Edexcel International Advanced Level Chemistry. Okay, as usual. So today we're gonna study Unit 5, General Principles of Chemistry 2, Transition Metals. Blah, 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 blah. Okay, the recent question paper, that is Jan 2017. So fellas, at first I'm really sorry for not uploading videos in the past months. It's been a year, I know fellas, but it's it's been a difficult time for me to upload videos in these recent weeks, in these recent years or whatever. It's been a long time, I know. So let's keep that thing aside. Okay, so now let's get back straight to the question. Okay, since this question paper is really hard for most of the students, so we're gonna go through the question in details. Okay, so here, since most of the question is conceptual and a little bit tricky, so we're gonna discuss in details about each question. So I'll provide the whole question paper in series. Okay, so in a uh, what I should say, it should be in a series. Okay, so it would be easier for you to understand. So we're gonna discuss each and every question with concept related to that question. Okay, relevant to that question. So okay, let's get back to the question. So okay, so this is the first question. Okay, section A, as usual, question number 1. So before starting the tutorial, okay, uh, we all know that the unit 5 of A levels chemistry is really hard, but if you know the concept, it would be easier. Okay, since it is easy to gain marks in this question paper, so it is very easy to gain mark if you know the concept, and I know that the concept is really hard as well as for me. Okay, so we will discuss each question with the concept, with the details, with the concept in details regarding this question. Okay, regarding each question we're gonna discuss each question with its concept, all the possible concepts that are related to the question. Okay, so that is why the question that is why the solution might get lengthy, that is why the video might get lengthy. So I'm really sorry for that fellas. So we're gonna go in details about the concept, that is regarding this regarding the question. Okay, so now let's get back to the question number 1. Okay, let me zoom this thing a little bit. Okay, fine. So this is section A of unit 5 of Jan 2017. so this is the recent question paper. So we are going to solve the recent question paper. Okay, so here this is written blah blah blah. Okay, whatever. So here in question number 1, it says, which set of successive ionization energies in kilojoule per mole could not be for a transition element? Okay, so as you can see that this question is related to the chapter transition element. So we gonna use the concept of successive ionization energies of transition element or d block element. Okay, so before answering this question, let us know all the possible concept regarding this question. Okay, so for that we need to go to the whiteboard. Ta-da. Okay, so first let us answer some of the question that may arise. Okay, so before answering this question, this typical type of question, we need to answer some question. Okay, so where is my marker? Here is my marker. Okay, so first of all, let us know how electrons are removed from d block elements. Okay, so before answering this question, we need to know that how electrons are removed from d block elements. So how electrons are removed from elements. So before writing anything, let me tell you one thing, that my handwriting is really bad. Okay, I'm really sorry for that, fellas. I know your pain. Even my teacher gets scared after seeing my handwriting as well as my language. As you all know that my language is little bit creepy. Haha. Okay, don't worry, it would get fluent with time. Okay, I'm learning from you, fellas. You are the most motivated people. That is why I am making videos for. Okay, you are the main motivation for making videos. Well, so let us first answer this question: how electrons are removed from d block elements. D block elements. Okay, so let us know the process how electrons are removed from d block elements. Okay, so before answering this, we need to know that all transition metals are d block elements. Okay, so all transition metals are d block elements. All transition metals are d block elements, but not all d block elements. Sorry, this should be block. D block elements are transition metals. Okay, so this is the key point. Okay, the key point of this solution. So we should consider all transition metals as d block elements. So all transition metals are d block elements, but not all d block elements are transition metals. Okay, so here is the concept. When a d block element loses electrons and forms a positive ion, the outer 4s electrons are always lost before any 3d electrons. Okay, so in a transition element, since it is a d block element, so the last electron is been filled in the d block, so that is why it is called d block element, as you all know. So in here, when a d block element loses electrons and forms a positive ion, the outer 4s electrons are always lost before any 3d electrons. So this is the case. Okay, so when a d block element loses electrons and forms a positive ion, the outer 4s electrons are always lost before any 3d electrons. So how should I explain this thing? Okay, let us draw the configuration of titanium. Okay, so this is the configuration, electronic configuration of titanium, which is Z is equals to 22. This should be like this: 1s2, 2s2, 2p6, 3s2, 3p6, 3d2, 4s2. Okay, so this is titanium, and titanium is a d block elements. Titanium is obviously a d block elements, okay, as well as transition metal. So here, in here, titanium is d block elements as well as the transition metals. Okay, so here what we were talking about here, let us get back to that point. When a d block element loses electrons and forms a positive ion, when this d block element loses electrons and becomes positive ion, the outer 4s electrons are always lost before any 3d electrons. So the outer electrons, these are lost before any 3d electrons. So outer electron, that is the 4s electrons, would be lost before these 3d electrons. So this is the case. So here these electrons of 4s would get removed before these 3d electrons. So before removing 3d electrons, all 4s electrons should be removed. So these electrons should be removed first. Okay, these 4s electrons should be removed first. Okay, so these 4s electrons should be removed first. So the outer 4s electrons are always lost before any 3d electrons. So why this should be the case? So let's see why this should be the case. Losing all the 4s electrons makes the ion smaller. So if we lose all 4s electrons, okay, if we lose all the 4s electrons, we will see that the ions become smaller than its original atom. So the size becomes smaller. So this is the key point, size becomes smaller, size becomes smaller. The size becomes smaller. So if we remove all 4s electrons, one shell would be removed, so the size will automatically become smaller. Okay, so losing all the 4s electrons makes the ions smaller, and then if it had lost its 3d electrons, this makes the lattice enthalpy and hydration enthalpy more exothermic. Okay, so since the size becomes smaller, this makes the lattice enthalpy and the hydration enthalpy more exothermic. Okay, since size becomes smaller, so this makes the lattice enthalpy and hydration enthalpy more exothermic. Okay, so as a result, overall enthalpy change for the reaction becomes more energetically favorable if 4s electrons are lost. So this makes overall del H more energetically, sorry for my handwriting fellas, my handwriting is little bit slow. Okay, don't be angry for that, stop scolding me, I'm crying. Okay, I know that I'm really small, I'm really slow writer. Okay, by the way, this makes overall enthalpy change more energetically favorable. So this makes more energetically favorable, which enthalpy change. So this makes overall enthalpy change more energetically favorable. Okay, so if all 4s electrons are lost, if all 4s electrons are lost, fine. So let us review these points once again for the question. So we are answering this question, okay. Before solving the problem, we are answering this question: how electrons are removed from d block elements. All transition metals are d block elements, but not all d block elements are transition elements, okay. So here we have discussed the structure of titanium, okay. Here the first electrons, the first shell, that is the first subshell that is need to be empty or removed is 4s. So all the 4s electrons are removed first over here. So here over here all the 4s electrons are removed over here, and then 3d. So here all the 4s electrons are removed, and then we will remove 3d electrons, okay. So all the electrons should be removed from 4s subshell, okay. So why we should remove from 4s subshell rather than 3d subshell? Let's discuss. Since if we remove since removing all the electrons from 4s subshell, the size becomes smaller. If we remove all the electrons from 4s subshell, size becomes smaller. Point number 1. Point number 2 is this makes the lattice enthalpy as well as the hydration enthalpy more exothermic. So as a result, this makes overall del H more energetically favorable if all the 4s electrons are lost rather than 3d electrons, okay. So have you understood these concepts regarding the problem? If not, please let me know in the comment section, okay. I want your feedback. All I want is your feedback, fellas, okay. So please give feedback. Don't forget to give feedback. I really love feedbacks from your fellas, because the only effort I give is for you fellas. This is only for you fellas. I make solution only for you fellas, so that's the reason, okay. If you give feedback, I get inspiration for making more videos, okay, in future. So this is the first part of the concept. Next we will move on to the second part, okay. So now we will discuss the trend in ionization energy in d block element, okay. So how ionization energies varies in a d block element, okay. So before answering this question, we need to know that the electronic configuration of titanium, okay. So the titanium, once again let us write the electronic configuration of titanium, which is Z equals to 22. At first let us know the electronic configuration of titanium, which is 1s2, 2s2, 2p6, 3s2, then 3d2, 4s2, okay. So now let us talk about the trend in ionization energy in a d block element, okay. So how does the ionization energy varies from shell to shell, okay. So we have discussed this earlier in unit 1 of chemistry. That was about S block elements or P block elements, whatever. but now we are discussing the trend in ionization energy in a d block element. So this is a little bit different from the previous concept. Okay, now let us look at this concept. So in here if we look at this configuration, here we're gonna have gradual increase in ionization from 4s subshell and 3d subshell. Okay, so there is no difference, or we can say that there is a little difference which is negligible of ionization energy between these two subshell. Okay, so if we remove all the electrons from this subshell, that is 4s subshell, the ionization energy of this subshell will be similar from this subshells ionization energy. Okay, so the ionization energy of these two subshell will be similar. Okay, so let us look why. Okay, so why there is a gradual increase while removing 3d and 4s electrons. Okay, so now let us discuss the points why there is gradual increase while removing 3d and 4s electrons. Okay, why there is gradual increase while removing 3d and 4s electrons. Okay, the energy levels of the 3d and 4s electrons are very similar in d block elements. The energy, this is the reason, one of the reason why they have similar or gradual increase in ionization energy while removing 3d and 4s electrons. The energy levels of the 3d and 4s electrons is skeletons. Chemistry is a bunch of skeletons, especially the organic chemistry. Oh, scary, right? Yeah, the organic chemistry of unit 5 is really scary, and it has the most complicated concept among A levels chemistry. In the A levels chemistry, I know benzene, mechanism of benzene, then nitrobenzene, phenol, blah 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 blah. We're gonna discuss this in this question paper later on. Okay, let's just concentrate on this concept. Okay, for the time being, the energy levels of the 3d and 4s electrons are very similar in d block elements. The energy level of the 3d and 4s electrons are similar. Why am I writing smiley? Similar. I was about to write smiley. Sorry for that, fellas. Are very similar. Where is my duster? Eraser. Are very similar in d block elements. So the energy levels of the 3d and 4s electrons are very similar in d block elements. So here is the trick. The trick is the energy levels of the 3d and 4s electrons are very similar in d block elements. Okay, so they are very close to each other, which makes them twins or identical. Okay, so since they have very similar energy levels in d block elements, so that makes the ionization energy similar. Okay, so the ionization energy of 3d and 4s electrons are similar. The ionization energy of 3d and 4s subshell is similar. Okay, so that is the reason behind that thing. So how this should vary with shell to shell? Okay, let's discuss. since these two subshell are identical, since they have very close energy levels, okay, since they have very close energy levels, so their ionization energy varies similarly or linearly. So the ionization energy varies from 4s to 3d subshell is linear or similarly. They will have close ionization energy while removing all the electrons from 4s subshell and all the electrons from 3d subshell. They will have similar ionization energy, just as removing electrons from one subshell, as if we are removing electrons from one subshell. That's the thing. Okay, the ionization energy change is really small, is so small that it as if we are removing electron from one subshell. Let me remind you one thing, that if we remove from the previous knowledge, let me remind you one thing from the previous knowledge, that if we remove electrons from the same subshell, the energy change is really small. The ionization energy change is really small. Have you recall it? Yeah, you were right. Just as that, the energy change of ionization energy, the ionization energy change between these two shells will be so close, just like that, as if we are removing electron from one subshell or same subshell, just like that. Okay, so now here comes the concept of big jump. So when it should be a big jump, so let's talk about the big jump. Big jumps from the sky, skylifting, skydiving. So when should be the skydiving? When should we skydive? Let's see. So the big jump will happen, not justice is not preserved, jump. So the big jump comes after all the (4s) and 3d electrons have been removed. Okay, so the big jump comes after all the 4s and 3d electrons have been removed. So the big jump comes after all the 4s and 3d electrons have been removed. So by this meantime, you can assume that the big jump will be from here. So the big jump start from here. Okay, so after removing all the electrons from 4s subshell and 3d subshell, we're gonna have a big jump over here. After removing all the electrons from 4s to 3d, then we gonna get a big jump in ionization energy. Then ionization energy will have a skydive. Okay, big jump from the sky. Big jump of ionization energy. I know fellas, the time is running out and it is taking so much time to solve one question. I really know, but what to do, fellas? Unit 5 is really hard and I need to explain in details about concept by concept, explain in details concept by concept in details. Okay, and I'm going really slow in order for you to understand, in order to make you understand. Okay, so what to do, fellas? Just stay along with me, don't go away, fellas. Don't leave me in the desert, fellas. I love you, fellas. Okay, so the big jump comes after all the 4s and 3d electrons have been removed. So the big jump comes after this, as you can see. Since these two have similar energy level, so this will have similar ionization energy or gradual increasing ionization energy, then it will have a big jump. That's it, as simple as that. So from here we can see that for an element to be a transition metal, it should have at least 4 ionization energy with gradual increase. Okay, so it should have at least 4 ionization energy with gradual increase. Okay, that was the last part of this concept. Okay fellas, by the way, it should have at least 4 ionization energy with gradual increase. Okay, so for an element to be transition metal, it should have at least 4 ionization energy with gradual increase. I hope that you have understood. You haven't? Okay, let me repeat this once again. So for an element to be transition metal, it should have at least 4 ionization energy with gradual increase. Okay, so this is the condition. Since the very first transition metal is titanium, since here we can see that to remove 4 electrons, total 4 electrons from 4s and 3d subshell with similar energy level, we need to have 4 ionization energy. Okay, so there should be 4 ionization energy involved to remove 4 electrons. Okay, so since we are removing 4 electrons from these two similar subshell, so they're gonna have gradual increase. So how they are supposed to have gradual increase, we will come to know while solving the question. Okay, so for the time being, let us know that it should have at least 4 ionization energy with gradual increase. So for an element to be transition metal, it should have at least 4 ionization energy with gradual increase. So I have repeated this 4 times. Sorry fellas, it's been a lot. Okay fellas, let's get back to the question which we were solving. Okay fellas, have patience. We are end of this solution. We have come too close to finish this solution. Okay, so don't go away fellas. I really love you fellas. I don't want to hurt you. Have patience fellas. Okay, the question, let us read the question. Question number 1: which set of ionization energies in kilojoule per mole could not be for a transition element? Okay, so here options are given. So from the previous concept we have come to know, so for an element to be transition metal, it should have at least 4 ionization energy with gradual increase. Okay, so to match this concept, let us at first find which are the transition elements. Okay, so which are the successive ionization energies of a transition element. So according to the condition was 4, at least it should have at least 4 ionization energy with gradual increase. 4 ionization energy with gradual increase. Okay, yeah, you know by this meantime, but for the sake of understanding, I'm writing this down once again. Okay, so let us at first find which are the 4 ionization energy with gradual increase. So these first 3 have the ionization energy with gradual increase. Here there is not much difference. Here there is not much difference. Here we have not much difference. So by this thing we can conclude that the electrons are being removed from 4s and 3d subshells. Okay, so this is how it goes. Okay, since they have linear increase in ionization energy, so these three are transition element. Okay, so these three are the transition element, or these are the set of successive ionization energies for a transition element. Okay, so so here we can say another thing is that there is no the electrons has been removed from 3s and 4d subshell. Electrons are removed from 4s or 3d subshell. Okay, so since there is gradual increase, so these three are the successive ionization energies in kilojoule per mole for transition element. Okay, but for D we can see that, by the way, D should be the answer. Okay, so this should be the answer. D should be the answer. Okay, so why D should be the answer? Why not these three? So by this meantime you have came to know why these three shouldn't be the answer, since these three are the set of successive ionization energies for a transition element. Okay, so D should be the answer. So why D should be the answer? Here as we can see that here the big jump is after these two ionization energy. There is a big jump big jump big. So here in D here we can see that after two ionization energies there is a big jump between second ionization energy and third ionization energy, which is unexpected for a transition element. Okay, so since there is no linear increase in ionization energy up to 4 ionization energy, so this shouldn't be the transition metal element. Okay, so the big for D being the answer, okay, why? That's because big jump is at third and fourth. Okay, and we know that the very first transition element is titanium, and for titanium we have seen that the first 4 ionization energy is linear, but in here the first 4 ionization energy is not linear, or we can say that there is no gradual change in first 4 ionization energy. Okay, third and fourth. So since there is a big jump in third and fourth ionization energy, so this shouldn't be the transition metal element. For an element to be transition metal, it should have at least 4 consecutive or 4 similar ionization energy. Okay, so this is the reason behind this thing. Okay, so for an element to be transition metal, this should be at least 4 ionization energy with gradual increase. Okay, then electron are removed from, that is because electrons are removed from 4s or 3d subshell, and in here D is not the transition metal element. Why? That's because there is a big jump between third ionization energy and fourth ionization energy, sorry, second and third. What I am saying, I'm going mad, fellas. Second and third, what am I learning through this year? Bullshit. Second and third. Okay, so since there is a big jump between second and third ionization energy, so this is really unexpected, and that is why D shouldn't be transition metal element. Okay, so that is why D should be the answer. So fellas, I hope that you have understood the solution as well as the question. So fellas, I hope that you have understood the question as well as the solution. So if you have any question or confusion regarding this solution, please let me know in the comment below. Okay, so fellas, can we get 100 likes on this solution? Okay, it would be highly appreciated if you give 100 likes. Okay, let's see, let's have a hope, or let's have a dream of getting 100 likes or 100 dislike will make no problem, just at least give your feedback. Okay, you may give 100 likes or 100 dislikes, it's up to you. Can we get